We discussed immersed optical system effective focal length. Now we want to talk about immersed optical system principal plane. So let's review the parameters that we discussed before. We have a thick lens. Here is the front focal plane that we use capital F. Back focal plane that we use F prime. And vertex, this is the principal plane, back principal plane. And the thickness of the lens is D. So the distance from the front focal plane to the vertex is front focal length, and the distance from the last surface to the back focal plane is back focal length, and the distance from the focal point, front focal point, to the principal plane is effective focal length, and we have the same for this side. From the principal plane to the focal point is effective focal length. So we should find effective focal length for each lens. And the distance between the first vertex and the second one is D. Now, let's say we have a situation that our optical system is immersed. So we have N on the left hand side, N prime on the right hand side. So all the parameters is going to change. Some things that we need to be very careful is that the distance from after you find the effective focal length using the equation that I explained before that included N1, N2 or N and N prime, then even using that effective focal length or modified effective focal length, for the distance from the front focal plane to the principal plane, front principal plane, this distance was effective focal length, but here is N effective focal length, the refractive index of the material that is in between. And for the other side also is N prime times effective focal length. So N times effective focal length, N prime times effective focal length. And the back focal length, based on the definition, is the distance from this surface to the back focal plane. And the front focal plane is here, and front focal length is the distance from here to there. So now the question is that how we can calculate the principal planes. So let's review for a lens that on both sides we have air. This is the effective focal length. For a material that is immersed, for a lens that is immersed into two different materials, we have this effective focal length. We need to memorize this equation. This is a very important equation, N minus N1. So be careful about the sign convention in this equation. And now, when we find our effective focal length, which is this number, then we can use that number in order to find the H1 and H2. So now let's review for a material, for a lens that you have air on both sides. You find the effective focal length using this simple equation. And for H1, we use this equation to find H1 and H2. So something to keep in mind that H1 is related to R1, H2 is related to R1, H1 is related to R2. As you can see here, we have this equation. Now for a material with two refractive indices on both sides, H1, first you find effective focal length using this big equation, and then for H1 you have to put N1 times F, and for H2 you have to put N2 times F, and the rest of the equation is like this. So we have some kind of difference between these two equations that we need to keep in mind. The best way to calculate the nodal points and principal points and effective focal length, all the parameters, is that you can have your own spreadsheet and you put the numbers. When you change it, automatically your spreadsheet, like Excel, can show you the principal planes. So we have these two equations that we can use for finding principal plane of a thick lens.